Here we're going to learn two new terms, relative frequency and experimental probability. Most students think that it is exactly probability. You may say so, but there's a little bit different. We just raise a few examples here, okay? So, for example, here, you test 850% blood donors, and then you find the blood type is this one, A, B, or AB or O. And then you find that 221, 204, 51, and 374 respectively, the number of people. So the relative frequency is for blood date is 221 over 850. Okay, I count this one. The last one is 374 over 850. This is very similar to probability, but we call this one, you measure that it is 850. This is the frequency, we call it. So the corresponding for blood type O is the relative frequency, okay? Very similar to probability, okay? And now we're going to talk about experimental probability, okay? For example, tossing a coin, you know that the probability of head is 1 over 2, okay? But it does not mean if you really toss a coin 10 times, it is 5 to 5, okay? 5 head and 5 tail. No, because in the real world, it is not exactly the same. So in this experiment, they toss 10 times, only 3 heads, okay? 20 times, only 7 heads, okay? And then more and more, and then you find that if 80, there's 41 number of heads. And then you calculate the relative frequency, you can find that the relative frequency is approaching 0.5, okay? This is because there's a film telling us that experimental probability is actually very, very close to theoretical probability for taking many experiments, okay? Okay, for taking many experiments, you see that experimental probability is very close to theoretical probability. And then we'll see that an example, if we record the number of tropical typhoons in Hong Kong, okay, sometimes 2 times, and then sometimes 7 times, and then sometimes 11 times, okay? It is very rare that too many typhoon, okay? And then we see that exactly 8, okay, exactly 8, so we highlight here, exactly 8, okay? So you see that this only 6, okay, 6 cases, okay? But how many years? 40 years, okay? So 6 over 40. And then less than 5. Is 5 less than 5? No. So it is only these less than 5, okay? This is 2, 4, 3, and 4. The corresponding frequency is 2, 3, and 3. So you add them up, and then you get the answer, okay? This is about probability, or you call it relative frequency. Now we look at a few more examples. Here's 60 students, and then the number of musical instruments, they know how to play the musical instruments, okay? You see that don't know how to play 8 persons, okay? No more than 3 is 5 persons, okay? Find the experimental probability, only 1. That is 14 students, okay? 14 students. And then altogether, there are 60 students. So this is the answer, okay? If you know that 286 students can play 2 instruments, okay? Estimate the total number of students in the school. Let n be the total number. You know that n times the probability of 2, okay, which is 2, you look at this column, okay, and this is 33, over 60, the probability, it should equals to 286, okay? 286, okay? With the help of the calculator, 286 times 60 over 33, you find out that n is 520, okay? And then we look at one more from the data. Some under 30 years old, some over 30 years old, male and female joining a club. And then you are going to see the estimate probability of under 30 years old is 37 over 289 plus 289, that is these two numbers. And then how many peoples are there? The total is 37 plus 289 plus 31 plus 143, okay? And then this is the answer. Is it very easy? Okay, it is very easy. If part B, it is a male, you just look at these two adding up together, okay? Part C is a female and joins the club under 30 years old, that is 289, okay? Very easy. This part is very easy, okay?